Okay, so this is week 9, lesson 3, which is unbelievably similar to what you just did in lesson 2. The only difference, okay, and I'm going to highlight it for you right here. The only difference is that sometimes now you're going to have answers that are complex, meaning they may have i's in them, meaning you may have some square roots of negatives that you have to worry about, but it should be easy. This is not new material. All right, so if I'm trying to find the zeros, I know I need to set the function equal to 0. Okay, and your first method is always going to be factoring if you can. So let's see, can I factor this? I think I can by grouping. Let me try that. So I'm going to group the first 2 and the next 2. If I take an x squared out of here, I'm left with x minus 3. And if I take a 2 out of here, I'm also left with x minus 3. So if I continue my grouping process, I get x minus 3 times x squared plus 2. This 0, right? This root is very easy to see. And this one, when I set x squared plus 2 equal to 0, and I move that 2 to the other side, yes, it is negative, but you know how to deal with imaginary roots. We're going to have plus or minus. The negative sign underneath comes out as an I, and the 2 will remain underneath. So you still end up with 3 roots as expected. 1 of them is real, 2 of them are imaginary. Okay, so let's move this up. Let's try this next one. All right, now, again, you're always going to try to factor first. This is factorable. It is a difference of cubes. So if you remember the difference of cubes sort of setup, the factoring should look like this. And again, one of these roots is easy to find. It's a fraction, but that's no big deal. It's a real root. But this part, this trinomial, when I set it equal to 0, it doesn't factor, right? It doesn't factor there. It's unfactorable, but that doesn't mean it's not solvable, right? We're going to fall back on the quadratic formula. So I'm going to have negative b plus or minus the square root of b squared minus 4ac. Well, I just screwed that up because I just realized that I put in the wrong number for b. Let's try that again. Right there. Okay, sorry guys, I am human, but b squared is 4, not 16. There we go, all over 2a. Negative 2 plus or minus, let's see, this becomes 4 minus 16 or negative 12. All right, when I simplify that radical, I get what, 2i rad 3 all over 8. And because 2, 2, and 8 are all divisible by 2, that means this fraction is reducible. Okay, that's the wrong color. Okay, so I divide all of those by 2, I get negative 1 plus or minus the square root of, excuse me, I forgot the I. There's an I rad 3 all over 4. All right, and then scooting it up, last example. All right, again, this would be fantastic if it factored, right? But it doesn't factor. There's no GCF. It doesn't work by grouping. So I'm going to have to go back to synthetic division. 1, 2, 2, 1. I'm going to try negative 1. Bring down the 1. When I multiply, I get negative 1 and add. Multiply, I get negative 1 and add. Multiply, I get negative 1, which gives me a 0, which is good. That means I have found one of my zeros. But the other 2, right, because I'm looking for 3 total, are going to be found sort of from these coefficients. X squared plus x plus 1 equals 0. So quadratic formula, here we come. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 1 plus or minus, let's see. This is 1, that's negative 3, which means as soon as I pull the I out, right there, I should have my other 2 answers. So my 2 imaginary or complex answers along with my 1 real root.